Today we are going to add Wi-Fi to a 3D printer, but this time I think it's going to be much easier. Now we have added Wi-Fi to a 3D printer before with a standalone ESP8266 module, some wires, and some configuration. But Eric reached out to me over on Twitter and said there's a much easier way to get this done. And that's with a Panucatt Wi-Fi backpack device. You plug it directly into the back of your LCD screen, then you plug your main board in the back of that. There are a couple of UART pins you need to set up, but that handles the Wi-Fi connection, the software, and it has access to the SD card, so handling G-code should be a lot easier. So here's a look at the backpack we're going to be dealing with mainly today. This is for the Rip Wrap discount display. You can use it on the full graphic or the 2004. On this side, you plug in your existing mainboard wires that already go to your LCD. This side, you can plug it into the back of the LCD screen. They also have this module that works with the Vicky 2. It's the same kind of deal. You plug it into the back of the screen from here, then you plug your wires in front. They also have an Ethernet module and an antenna that you can use on these modules to extend your range. So that's what we're going to do today. We're going to get the Wi-Fi device set up and configured. We're going to test it out, try it on a couple of different boards. Again, we do have a couple of UART pins that we need to set up, but that should be pretty straightforward, and we'll walk through it step by step. So let's get to the config. So as usual, I like to start out simple, so we're going to use our ramps board with our 2560 and our 2004 display. So if you're adding this to an existing 3D printer, when you remove your cables from the back of your LCD screen, make sure you remember exactly which way they go, which one goes where, because you're going to be able to put your backpack on here and then put your cables right back on the backpack. You want to make sure they're the same orientation as when you took them off. So for the 2004, on your backpack module, you're going to use these two lower ones right here. And it just plugs in right like that. And then you can put your LCD cables right back on the panel, right where you found them. My cables go just like this. Now we're going to have to add those UART pins that I was talking about, the transmit and receive. They're right over here. So for our receive wire, let's use yellow. These are the wires they give us with the backpack. And then for transmit, we'll use the white one. There is one empty pin down here on the bottom if you can't see it. And on the ramp side, we're going to use our AUX1 pins, the transmit and receive pins right down here. The outside one is going to receive. The one right next to it is going to transmit. So the white wire, the transmit wire coming from the backpack, will go on the receive pin right here. And then the receive wire, the yellow one from the backpack, will go on the transmit pin right here. And that should be all the wiring we have to do to get the backpack to work. Now we can power up the board and check out the configuration steps. I powered the board up, our screen still comes on, so that's a good sign. So let's head to the computer. Now if we come to the corner in Windows and we click on this screen, we can check out our Wi-Fi networks. You'll see one that says Wi-Fi backpack. That's because by default, when the backpack boots up, it's an access point, so we can configure it. So let's go ahead and click on that. We'll hit connect. And the default password is 12345678. We'll hit next. And when it connects, it should automatically open a browser window for you. If that's your only connection to the internet, it will probably transfer you to the correct IP automatically. If not, we can punch it in the URL bar. It's 192.168.0.1. And this will get you to the main control screen of the Wi-Fi backpack. This is using ESP3D software, the same stuff we used when we did the ESP8266 video. It's just been updated and tailored towards the Panucatt device. So let's start the initial configuration wizard. We'll click up here on the right. We'll click Setup. Pick your language, English. I'm going to use it on a Marlin-based printer. I'm at 250,000 baud rate. And the name of the Wi-Fi backpack, I'll just leave it at default. You might want to change this to your printer name if you'd like. Hit continue. The default is access point, so we can connect up to it to configure it. I want it to join my Wi-Fi network so I can get to it from any computer in my house. So I'm going to switch it to station. We'll click set. We'll enter my Wi-Fi network name. Remember, these are case sensitive, BC Wireless. We'll hit set. And then your Wi-Fi password. The backpack is connected to an SD card via the screen, so we'll leave that as yes. And you can update this backpack via the SD card, so we'll go ahead and leave that yes as well. So click continue. Setup is finished. We'll click closed. Now we'll just go ahead and power the whole printer off and then back on. And when you restart your board, it should come up with a connecting message. And then you'll see the IP of your new backpack. That's where we can connect up to the printer. If you don't get the IP, you can try to hit the reset button back here on the backpack, this one here. Sometimes the backpack can restart faster than the printer, so sometimes you have to reset it to get it to display that IP. And if neither one of those is working, there's a couple of different ways you can get that IP. If you know how to log into your router, that will let you look up the IP address. Mine is 192.168.1.100. I can tell because it's only been online for 2 minutes. But also, you can ping that Wi-Fi backpack. If you come down to the Windows key and you type in CMD for command prompt, you can do ping and the name that you configured when you did the setup of your Wi-Fi backpack. By default, it's called Wi-Fi backpack. And hit enter. The ping should be successful, and it's going to show you the IP address of that backpack. We can take this, we can open up a new tab, enter it in our address bar. Now we're connected up to our backpack via our Wi-Fi network, so we don't have to jump onto the AP every time we want to connect to it. We can see the printer's online. We're starting to get temperatures for the heater. If you head to the printer tab, you can hit refresh and see your current configuration. This will let you adjust a lot of the same things that you can adjust in EEPROM if you'd like. And now that we're on the Wi-Fi network, you can actually go to the ESP3D tab and adjust a lot of those settings that we did in the wizard if you'd like. So back to the dashboard. The biggest drawback to the ESP8266 module was that it took forever to upload G-code files. So let's test that out. You still do have to use the 8.3 rule for now, an 8-character SD file name with a 3-character extension. So you're going to want to use .gco when uploading to these modules. So let's jump out and find a G-code file. Let's take this Benchy G-code right here, and we'll rename it. We'll keep it 3D Benchy for our file name. That's 8 characters. And we have the full word G-code by default out of Slicer. So we'll just make it GCO. And we'll hit enter. Now let's jump back to the web interface, and then we'll hit upload, and we'll find our GCO file that we created right here, and we'll hit open. And that will start the upload going to the SD card that's on your screen. Now I am quite a ways from my router, but I can already tell this upload is much faster than the previous Wi-Fi config that we did before. And that upload took less than 45 seconds. And when it uploaded, it also gave us a list of everything that's currently on that SD card. Everything else in the software works exactly like you'd expect it to. It's pretty straightforward and intuitive. So it's working on ramps. We can see the status of the thermistors, we can get all of our printer config information, and we can upload G-code successfully, and it appears to be much faster. So that's good news. Now what about a few other board configurations? Let's try it on an MKS style board. It should be pretty close to ramps, but let's make sure. So here's our MKS configuration. I didn't move the UART pins at all. They stay exactly the same. But the LCD cables compared to ramps are actually upside down on the MKS style board. So I just turn these upside down on the backpack side of things, and that should make it work. Again, everything else is the same. We've got our 2004 display. And on the board side, it's pretty much exactly like ramps. We're going to use our AUX1, the pins on the top row right here. This outside pin is the receive pin. The one next to it is the transmit pin. So we hook the transmit pin from the Wi-Fi backpack to the receive pin, our yellow wire, and the receive pin from the Wi-Fi backpack to the transmit wire, our white wire. And we'll go ahead and power up, but it's going to be almost identical to ramps. It's going to boot up, the Wi-Fi backpack's going to boot up and connect, and then it's going to hand you your IP address. And on the web interface side of things, it might be a different IP address, but it's going to tell you that on the screen of the printer. And since we're running Marlin, it's going to be almost identical. Nothing really changes. It can interact with the printer exactly the same as it did on ramps. That's the nice part about these devices and this ESP3D software. It's one size fits all. You can take it from printer to printer and it'll all work the same. So it works on ramps and it works on MKS. But it's probably important to mention that if you're using your USB interface on your board, maybe with something like Octoprint, using both the backpack and the USB interface at the same time can cause conflict and throw some errors. So watch out for that. It might not let the backpack work if the USB cable's plugged in. So we're good on 8-bit technology, but what about 32-bit? How about we test it on everybody's favorite board right now, the SKR 1.3. It works pretty much the same way, but to enable those UART pins, you need to make one tweak in Marlin. It's pretty straightforward, so I'll walk you through it step by step. So on the SKR, I was able to flip the cables back over to how they should be, the same as ramps. So this is the bottom of the board, this is the top of the board, cables going down, red stripe to the bottom left. Again, the same 2004 display. And on the SKR side, just put the cables in where the notches fit, just like this. And then for your UART pins, we're going to use these pins down here labeled TFT. I'll go ahead and remove these wires and show you how I connected them. And on these TFT pins, these 5 right here, the one that's closest to the LCD connectors, you can skip that one. The next one is going to be your receive pin, and the next one is going to be your transmit pin. So our yellow wire that's coming from our backpack, on the backpack side, that's the transmit pin. It will go to the receive pin right there. And then the white wire, our receive pin on the backpack side, goes to the transmit pin on the board side right next to it. Just like that. And you can go ahead and power on your board and cable up USB, or just pull your SD card, because we are going to have to make a change and flash Marlin really quick. So we'll jump into Atom, and this is our configuration that's already configured for the SKR 1.3 board. This is Marlin 2.0, 32-bit. We'll just scroll down a little ways, and then we get to the serial port section. Your default serial port is -1. But then under that, you have this secondary serial port that's available. That's the one we want to use for this Wi-Fi connection. So just take the comment off of that line. Define serial port _2. And we're going to leave it at 0. That should work just fine. That's the only change you should have to make to be able to use those transmit and receive pins that we hooked up to. So if you're connected up to your board or you have your SD card mounted, you can go ahead and hit build and upload. And then when you've reflashed and the board starts to boot up, you should see connecting and then your IP address. Remember, if the backpack starts up faster than the board, just use that reset button on the backpack to get everything corrected. And again, on the interface, everything's going to remain the same. Your IP might change, it's going to tell you that on the screen, but all the other controls are going to be identical, including how you interact with the SD card on the screen. You're not interacting with the one that's on the 32-bit board, this is the one that's mounted on the LCD. And there you go, adding Wi-Fi to a 3D printer the easy way. And the best part, these modules are less than $17 available over on the Panucatt site. And I have contacted Panucatt support with some questions that I had about the module, and they were very responsive. So definitely check them out. All the information will be in the description below. Now, not every 3D printer is going to have exposed UART pins that you can use with these modules, so definitely research that before you purchase one. I know on Prusa printers, the Mini Rambo and the Einstein, you're not going to be able to do that easily. So definitely check that out. Hope you liked this video or you found it helpful. If you did, please consider giving it a thumbs up or subscribing to my channel. If not, leave your thoughts in the comments below. And as always, thanks for watching.